Because of the structure of alcohol, it is what's called both water soluble and fat soluble. What that means is when you drink alcohol, it can pass into all the cells and tissues of your body. It has no trouble just passing right into those cells. So unlike a lot of substances and drugs that actually attach to the surface of cells, to receptors as they're called, little parking spots, and then trigger a bunch of downstreams like domino cascades of effects, alcohol actually has its own direct effects on cells because it can really just pass into those cells. And the fact that it can pass into so many organs and cells so easily is really what explains its damaging effects. Okay? It produces substantial stress and damage to cells. I'd love to be able to tell you otherwise, but that's just a fact. Because when you ingest ethanol, NAD and related biochemical pathways are involved in converting that ethanol into something called acetylaldehyde. It's broken down into acetylaldehyde. And if you thought ethanol was bad, acetylaldehyde is particularly bad. Acetylaldehyde is poison. It will kill cells. It damages and kills cells, and it is indiscriminate as to which cells it damages and kills. So it's important that your body be able to do this conversion very quickly. And the place where it does that is within the liver. And cells within the liver are very good at this conversion process. But they are cells, and they are exposed to the acetylaldehyde in the conversion process. And so cells within the liver really take a beating in the alcohol metabolism events. So the key thing to understand here is that when you ingest alcohol, you are, yes, ingesting a poison, and that poison is converted into an even worse poison in your body, and some percentage of that worse poison is converted into a form of calories that you can use to generate energy, generate ATP. And the reason why alcohol is considered empty calories is because that entire process is very metabolically costly, but there's no real nutritive value of the calories that it creates. You can use it for immediate energy, but it can't be stored in any kind of meaningful or beneficial way. It doesn't provide any vitamins. It doesn't provide any amino acids. It doesn't provide any fatty acids. It's truly empty calories. Now, the important thing to understand is that it is the poison, the acetylaldehyde itself, that leads to the effect of being inebriated or drunk. I think most people don't realize that being drunk is actually a poison-induced disruption in the way that your neural circuits work. And so we should ask ourselves, like, which neural circuits, what brain areas, what body areas involved in feeling drunk or inebriated? Now, in thinking about this state of being tipsy or happy or really drunk or a little bit drunk, for people that are regular drinkers or that have a genetic predisposition to alcoholism, when they drink, they tend to feel very energized and very good for longer periods of time. Again, people who have a genetic predisposition to alcohol, or people who are chronic drinkers, or even just, if you recall, chronic doesn't have to mean a ton of alcohol, but they're drinking 1 or 2 per night, or they're every other night type drinkers, or Thursday through Sunday drinkers. Those people typically experience an increase in alertness and mood when they drink, whereas occasional drinkers will have a briefer, meaning less long-lasting, period of feeling good when they drink, and then more quickly transition into a state in which they're tired, or they start losing motor skills, they start slurring their speech. In thinking about the biochemical effects of alcohol and what it's doing to the body, what it's doing in all cases is it's consumed into the gut, right? Goes into the stomach. The liver immediately starts this conversion that we talked about before of ethanol to acetylaldehyde to acetate. And some amount of acetylaldehyde and acetate are making it into the brain. It crosses the blood-brain barrier. Again, the brain has this fence around it that we call the blood-brain barrier, or the BBB. Many things, most things, thankfully, can't pass across the blood-brain barrier, but alcohol, because it's water and fat soluble, just cruises right across this fence and into the milieu, the environment of the brain, which is made up of a couple different major cell types, neurons, nerve cells, and so-called glial cells, which are in between the nerve cells. So what happens when alcohol gets into the brain that makes us feel tipsy or drunk, and in some people makes people feel really especially energized and happy? Well, alcohol is indiscriminate in terms of which brain areas it goes to. Again, it doesn't bind to particular receptors, but it does seem to have a propensity or an affinity for particular brain areas that are involved in certain kinds of thinking and behavior. So one of the first things that happens is that there's a slight, at least after the first drink or second drink, there's a slight suppression in the activity of neurons in the prefrontal cortex. This is an area of your neocortex that's involved in thinking and planning, and perhaps above all, in suppression of impulsive behavior. So if you go to a party and they're serving alcohol and people are consuming drinks, what you'll notice is that a few minutes into that party, the volume of people's voices will increase. And that's because people are simply not paying attention to their voice modulation. As other people start speaking more loudly, other people are speaking more loudly. We've all had this experience, right, of going to a party and then you step outside for a moment and you go, oh my goodness, I was shouting. You come home the next day, you got a sore throat. It might be that you picked up some sort of bug, some virus or something. But oftentimes it's just the fact you've been shouting all night just to be heard, because as the prefrontal cortex shuts down, people stop modulating their level of speech quite as much. Also notice that people start gesticulating more, people will start standing up and sitting down more, they'll start walking around more. If there's music on, people might spontaneously start dancing. All of this is because these areas of the prefrontal cortex normally are providing what's called top-down inhibition. They are releasing a neurotransmitter called GABA onto various parts of the brain that are involved in impulsive motor behavior and thought patterns. And as you shut down the prefrontal cortex, that GABAergic suppression of impulses starts to be released. So people will say things that they want to say without so much forethought about what they're saying. Or they might do things that they want to do without really thinking it through quite as much, or they might not even remember thinking it through at all, or experience, I should say, thinking it through at all. We haven't talked about blacking out yet and the effects of alcohol on memory. But as long as we're there, I'll just tell you that alcohol has a very strong effect in suppressing the neural networks that are involved in memory formation and storage. This is why oftentimes we forget the events of a night out if we've been drinking. Those brain areas basically shut down entirely, and people just tend to say what they want to say. So the key thing to understand is that when people drink, the prefrontal cortex and top-down inhibition is diminished. That is, habitual behavior and impulsive behavior starts to increase. Now, what's interesting is this is true in the short term, so after people have one or two, maybe 3 or 4 drinks. But it's also true that the more often that people drink, there are changes in the very circuits that underlie habitual and impulsive behavior. For the person that drinks, say, every Thursday night or every Friday night, or goes out only on Saturdays but every Saturday, there's evidence that there are changes in the neural circuits of the brain that control habitual behavior and impulsive behavior, and they are modified and strengthened in ways that make those people more habitual and more impulsive outside the times in which they are drinking. And when they drink, impulsive and habitual behavior tends to increase even further. This is something that's not often talked about when discussing the effects of alcohol. And we all know the effects of being drunk can be bad, right? Can be bad in terms of judgment, motor coordination. Certainly driving drunk is a terrible thing, get you or other people killed, and so on. But rarely do we hear about the changes in neural circuits from just 1 or 2 nights of regular drinking. Again, chronic drinking doesn't necessarily mean every day and every night. It could be the person that simply drinks every Thursday or every Friday, or just once a week has 3 or 4 drinks, or maybe even a few more. That person is going to experience a decrease in this top-down inhibition, so an increase in impulsivity and habitual behavior because the brake on those behaviors has been removed while they're drinking, but also changes in the very neural circuits that allow habitual and impulsive behavior to occur more readily even when they're not drinking.